Hello everybody, this is part one of the Avondale NCC300 power amp build. So we've got our boards, seen those earlier. Sorry, I just had to move the light. And we're going to start off by populating the positive rail, or the positive regulator for the positive rail that supplies this front end section here. So you diligently work out what you need. Bill of materials. Luckily, Avondale has supplied a bill of material on the board itself. So 10k, these are resistors, 6k2. The pot there is not identified what value it is, but I can tell it's a 2k2 or 2k. The capacitors, Panasonic, 10 of 100 volts, and so on and so forth. The heat sink and the tip 41A. I think when he sent these boards out, he sent a little pack of bits and pieces with it as well, and these you get a, I think most people have a bunch of these regulator heat sinks. I think he also sent out some capacitors and some other bits and pieces. This is a 10 off, I think it's a 10 off, whatever it may be, 100 off, sorry. This is 100 microfarad, 63 volt film type input capacitor. Hard to get hold of really, I think. And there's another one which is a solid aluminium type. Well, again, I'm trying not to be technical, but this is specific to this, and it's a 68 microfarad, and it goes in there. And on this you can see there's a positive marking, and that positive goes to the positive on the board there, like that, when we get round to installing it. But that'll be sometime later. There's also a coil of wire which goes in, which is an inductor really, which goes in there, and there's going to be a 15 ohm resistor through the center of this coil of wire, and that's your Zobel network. And again, I'm not getting don't want to get technical, but it's a very handy little device to help the amplifier perform at its best. So I think most that have these boards have these extra bits and pieces as well. If you don't, you've got to source them. I'm going to go down the route of I've got a list. Unfortunately, this is blue paper of requirements. This is my bill of materials to do this. So I need, for each board, I need 8 10k resistors, a total of 16. I think I've got 20 in stock, or I ordered 20 because I've only got 16 and I wanted a few extra. 6k2, now there's a funny one, 6k2, I buy most of my resistors from Farnell, and a 6k2 and a 28k, they don't stock that, they stock most other things, but you have to source those from somewhere else, and I buy them off a chap off eBay. The reason they don't stock it, I got no idea. It's obviously it's an odd size. What else is difficult? Everything else on here, you'll see on the board, the tip TIP regulator. This one here is a 41A, and on the other side 42A. Well, the A signifies its voltage, working voltage, or maximum working voltage, or its tolerance, if you like. And I've happened to have in stock the 41C, 42C, and that's just a higher voltage device. It's exactly the same, but it just works, or a higher current. I can't remember which, doesn't matter. So there's in effect a bill of materials for one, and obviously you've got to double up on all of those, and that's what I've done down this side. I've just doubled up what I have in stock and what I needed to order, and lo and behold, I ordered it, and today big bag come in. I already have a load of stuff here already in stock, but I needed some extra from Farnell. I'll just tuck my address out the way. There you go. So I placed an order the other day in Farnell. Lo and behold, next day delivery, free of charge, as long as you spend more than 28 quid or whatever it is, £24. They got it to me, very efficient. So that was handy. So we have a nice bag of bits, things like this, some screws to hold down the output transistors. We got some 100 of 63 volts. These are Panasonic's, and they are 105 degrees. Is it NGK or something they're called? They're designated. But they're good quality, a very good quality capacitor that we'll use in various places. Some transistors, some more output transistors. Now we're talking about resistors. This is predominantly, I'm going to be using MFR5, which are 3/4 watt, 1%. If this thing, there we go, 3/4 watt, 1%. Throughout. There are a couple that I do change, but the majority, that's what Avondale have used, that's what I'm going to use. You don't have to use them, you can use whatever resistors you like, as long as they're within, I'm going to say 5%. So that's those. I've got some other capacitors here, 100 volt, 10 of 100 volt. Without further ado, what I'm going to do is set myself up and start populating this board. And we're going to start with 10Ks. We use quite a few 10Ks in this build, so bear with me, I'll be back. 10Ks, I've just snipped the top off the packet. There they are. I'm just going to check the first one. Many people will check every single resistor that they put in their boards. Good idea. I tend to rely on the manufacturer supplying me with what they have sold me and what I ordered. 9.94, close enough for me, and I'm going to take it as read that every other resistor on this string is exactly the same. So I'm just going to use that as a 10K resistor and start populating this board, so we can move away from that now. We'll come back to that later. Again, many people, they clean the legs of the resistors with a blade. as if there's corrosion on it. There's no corrosion on that. There might be a little bit of transport stuff. It's as simple as it. We know this is a 10k resistor. I just bend them over like that. There's a spot in here, 10k, and I'll just drop it in there like that. A little bend on the legs on the underside, just like that, and we carry on. So on this side of the board there are 1, 2, 3, 4 10k resistors, and we're building up this one, so I'm going to install all 4. Not going to bore you too much, come back later. We also need a few diodes, 1N4007, 1N4007. I know these are correct. Just tear it off. There's a little bend and the bar, there's a little white marker bar on the diode, and there's a bar on the printed circuit board. And it's just a matter of tucking them in there. This is not the, I'm working around a camera here, but there you go, he's on there. That's fine. There's a couple more of these, so whilst I've got the packet out, I'm going to populate those as well. So yes, on this side of the board, boring, just populating a component as indented on the board, and you pop that in like that. On the board it calls for I bought these from RS, as you can see, 7.5 Zener diode BZX79C7B5. So that's little tiny things like that. So we just nip him off, and again there's a line, a bar, and we're going to use that to align the diode. So on the end of the diode there's a black line. That black line aligns with this here. Gently, these are a bit tiny. I leave them a little bit proud of the board. If you can see that, as opposed to pushing them right up against the board PCB. So 2 diodes fitted, a 10k resistors fitted. This is all what they call low level stuff, so this is all, if I turn it over, it's easy to solder. The board's not wobbling about. I used to have I've got one over the back of the bench there, a PCB mount where you can just swing it round, populate, swing it round. I tend to do it like this. Now, so we move on. These are 1k resistors now. So this is just boring. I'm going to carry on and just populate this board as per what's on here. So there's a 1k resistor going in at a 1k designation on the board. Simple as that. So I'm going to carry on doing that. I'm going to pop some capacitors on, and again it's just as the ident on the PCB. You pick up your capacitor and you pop it in there. The long leg of the capacitor is the positive side of the capacitor, so there's the positive side on the board, and you just drop it in like that. So I'm going to carry on and just populate this out, and when I've just before I move on too much further, we need to populate some small devices, some 2N555 and I think there's 5 of these. There's 1, 2, 3, 1, 2, 3 on this regulator, 3, 4. So there's actually 4 on we need. The others are BC 546s and 556s, I think. But I'll populate those out with these and carry on. As a precaution, if you have a little tester before you start putting transistors, and these are known as active components in the board. I mean, these are brand spanking new, they're not static sensitive per se, but it's always worth having a quick check. What have we got here? We got as NPN HFE 216, that's fine. So there's one, that one's fine. Drop this one in. If you haven't got one of these testers, then don't test it. Just take it on the face value that there's nothing wrong with it, it's fine. Or you can splash out, you know, I think they're about 20 quid, these little testers. They're not the most accurate device in the world, but they're pretty darn good at telling you whether the device is good or bad. Oh damn, good or bad. So that one's a diode. That's wrong. Now I've got to double check this. See, it's a good job, isn't it? It's a good job. Oh yeah. Oh. I'll do it in there in a second. Oh, there we go. It's in the wrong one. So yeah, all 3 of those devices are good. So I can go ahead and populate those on the board. So I'll drop those devices in their locations, and I've just neatly soldered them in place, nipped off the legs. Now what I want to do, I want to make up just a little pin as for a test point for the, here it is here, TP, test point for my probes at a later date when we start testing everything. So I've just used a resistor leg, as you saw. I bent the end over just slightly. I'm just going to solder that into position. I'm being really fussy about that really, because I wouldn't normally bother. You could actually, if you look at the circuit, this is the supply off this regulator that supplies this side, the positive side of this front end board. So you could actually come off any component here, down here, and that off any leg of these resistors, and that will give you the voltage that you're looking to set up. But look into that later as we move on. So now I'm going to put these capacitors in, and I'm going to put a spade in here, and I'm going to put a spade in here in the screen, because this screen is going to form the negative part of the negative supply here for when we start setting up this voltage reference for this. This is the way I is in actual fact I've got 21As tip. Can't sure you can see that. Tip 41A, and this is the way I use. The correct manner is you should put a sill pad between the device and the heatsink, and this is the way I'm going to do it. I'm not going to say it's the correct way, it's the way I do it, and it seems to work perfectly. This is just a piece of super glue, a little bit of super glue. You align the device in the holes, align it up to roughly where you want it, hold it for a few seconds, and that's the device in situ. We're now going to put the lid on the super glue. I'll probably get told off for that by a load of people. You shouldn't do that. It's the way I do it, and it's been very successful over the years. To solder this device in situ. There you go. Cut off the legs. And in effect, there you have one positive NCC300 regulator complete. I'm going to drop a spade in here. I'm going to put some voltage on it and see if we can do some measurements. I'm on my bench supply here. Excuse me. So across my bench supply, this is 50 volts, 53 volts across the bench supply. But we're going to be adjusting for this test point. I want 45 with the transformer we're going to be using. 35 volt, 35 volts AC on each secondary. That will give us around about the 50, 52, 53 volts DC we need to drive this power amp module board. So I'm going to hit the power up button off my bench supply, and there we have 52 volts DC supplying this regulator. Now I'm going to come off of there, a bit fiddly, and go on to the test point. Excuse me, just get moving things out of the way here. And we got 39 volts supplying the positive side of this front end board. Well, we don't want that. I want a 5 volt drop, so a minimum 5 volt drop. I want this to be about 45 volts. I don't know. Oh, wrong way, so it's anti-clockwise to increase. Gently, gently, gently. I'm going to go to 46 actually. $45, 46 volts, there we go. So no drama there. All works hunky-dory. So that's that element of the works complete. We've proved it, it works. I'm now going to go on and build up the negative side. The negative side used slightly different components. It's two N5401s. I think that's all the difference it is, actually. That's all the difference there is. But that's a negative regulator, so it's flipped the other way. But I'm happy with that so far. That's all good. See you soon. So I've built up this negative side here. It's exactly the same as the positive side, apart from these components. This one, and this one. These are two N5401s, and this is a tip 42 as opposed to a tip 41. This device here. So I'm going to put some juice on it, and we'll see where we are. Now I've twiddled this pot to be the same as this one, so we'll see how we get on. So this is off the bench power supply. You'll notice that this is the positive, this is the negative. Because this is the negative, we're running it back to front. So we use the positive rail as the earth that it would be, or 0 volts, and the negative as the negative supply to this regulator. So we'll crank it up to 50 odd volts. Uh, 54, something like that. So now we want to measure off the test point. Off the test point we have, no, that's wrong, sorry, wrong way round. This stays as the negative, this is the, there we go, 46.3. I'm a little bit out, so I'm just going to wind this back to 46. Now it was wrong way, it's clockwise to decrease. There we go. So we've got 46 volts negative on this regulator. So that part is finished. Obviously I'm doing one board at a time here. When this board is complete, I will do the same process on the second board, and we'll work through that way. So I'm going to start to populate this. Again, it's just a straight ident. We've got 2K7, so I'll put a 2K7 resistor in there, boom boom boom, so on and so forth. The bit that we haven't covered yet, I will do, RS2 sorry, and RS1. We've got no ident as to what they are. Well, I can actually tell you they are 15R resistors. The other one is this pot is the same as these. It's a 2K2 pot, trim pot like that. I think it's a 20-25 turn, something like that. And this obviously adjusts the bias, and the bias is set by putting the meter across RS1 and RS2. We'll cover that when we get to it. Oh, the other one here, there's a cap goes across ZTX653, and that's a 47 puff. I think that's the only one that's not idented. Yeah, that's it. So I'll carry on, populate this with the appropriate transistors. Up here we've got a 2N551. Well, this won't be put in this position. It's going to be put up here, and it's going to be coupled, close coupled to the actual heat spreader here, which we'll cover later. I'm going to cut out a little pocket for this to sit into, and it will be thermally bonded to this heat spreader, so we've got a thermal coupling that tracks, the bias tracks with the thermal energy dissipated by the transistors, the output devices. Anyway, I'm going to carry on and populate this component for component, solder it up, and we'll come back and we'll do a setup. Well, as promised, I finished this front end section here, populated 220 PFs. This is 100 microfarad, 10 volt, solid tantalum, military spec I believe. Avondale on lots of occasions supply these when the people bought this kit, in effect in its DIY form without anything else. You'll see the 2N5551 that normally goes here. Now I have soldered it to this location, and that'll become obvious in a little while. Again, these film caps supplied by Avondale, or you could use your own. Nothing else particularly fancy. 47 puff PF. So we've tested this regulator. We're now going to test this front end, and I'm going to run it off my bench power supply. So you need a naught, you need a negative supply, and you need a positive supply, just like that. Need the multimeter. We're going to go to volts. I'm just going to, there was a couple of pins I put in through the board like that. The circuit actually runs back dog legs to the end of this 15R, and this one does the same. This dog legs back to this resistor here from there, and this is how we measure our bias setting, if you like, if you want to call it that. And I'll just power up and I'll wind it up, and you'll watch, hopefully all being well. We don't want any more than 2 volts. Or thereabouts, 2 volts. And I'm driving 35 volts into these regulators. I'm not driving 50 volts, but I'm just proving that the offset is set for 2 volts as we stand at the moment, and that's fine. I could wind it back a bit, but I'm quite happy with that. That's good-o. So both regulators are working. The front end board is, or the section of the board is working, and we've got an initial bias set up there for when we move on and build up the amplifier, the output sections at the next stage, which is what I'm going to do. So before we go there, I'll just switch the power supply off. So if we look here, those pins I'm talking about, these test points I'm using here, we turn the board round. As you can see, it dog legs across to this 15R here. Now, this 2N5551, if that's better, it's focused. The reason why it's there is to thermally couple with the heat spreader, and it holds the amplifier in a steady state if one drives it quite hard. So let me get rid of this. My plan, my design, if you like, thus far, I've got a 400 long piece of U channel, and this U channel is, I think it's 38 by 38 by 5mm. Nicely drawn, and I've overlaid onto this edge that I'm going to be dropping these devices on. I've overlaid where I need to drill the holes. Simple as that. They are all, I drill 6, I'll go through the pilot hole 1mm or thereabouts, but all the holes end up at 6mm. And if I was, when I'm going to offer it up, you can see just here, I'm going to just nib this out with a file so that this will be nicely seated in there when all these holes line up, and this will be thermally epoxy resined to this heat spreader, so that this maintains the same temperature as this, and it will keep the amplifier at a stable state. If you have it down here, it could run away, but that's the plan. I'm going to have obviously one there, and the other one's going to go this side in tandem, as it were. So may or may not be a good idea, I don't know. I've never had any issues with them going wrong as such, so I don't need to think about long-term servicing, 10 years, something like that. It's going to go in the case it's not going to come out again. So that's the plan. We'll move on now to build up this output stage. I have, I think, all the gear, various on semi 15003, 15004s. I've got some high power resistors, these R22s that go in there. I've already used those. Just of note, there's something I've used elsewhere, and that's some of these. These are organic capacitors. They work very, very well in a single signal path as opposed to a tantalum. They're aluminium organic polymer, and I may try, and they go in here, so I might whip this out and try one of these, just to see if it adds or subtracts to the overall sound quality, but that'll be at the end of the job, and I'll have to come back and give you a or nay on that. So that's the next phase. This part is the heat spreader, which is my piece of aluminium as described before, and I've been along with my template and I've drilled out all these holes, deburred both sides, and now I'm putting in these nylon standoff shoulder washers, and can be a bit tricky. These are 6mm holes. These are 6mm little standoffs, Teflon, nylon, whichever, and they are a very, very snug fit as a 6mm hole. I actually have to, I don't know if that's in focus, I've got to press fit these in like that, and they become perfectly flat. And I'll go along, do another one for you. If that's in shot, I don't know. Oh. There we go. Boring, boring, boring. Monotonous, monotonous. There we go. And they form the basis of the standoff for the PCB. So the PCB is fitted under like that, all the way along. And as stated earlier, I've got to notch out a piece here for this transistor here, for this one here, which I will mark and cut out. Just file a notch out, and that'll be perfect. So, see you later. So I've notched out a little piece here and here, here and here, for the transistor on the power amp board to sit into. But I've noticed our nylon standoffs are just a tad, some of them are perfect, some of them are just a tad too long. I don't know whether that's the aluminium thickness or the nylon spacer, shoulder spacer, that's too long. We need this to be absolutely perfectly flat, or these need to be below the level of the aluminium, so the seal pad, when it sits on here, is totally flush with the aluminium heat spreader, and the transistor will sit on top of that, and there'll be a perfect close tolerance matching to get the heat away. So I can either put a spacer underneath these, or I can just slice a few thou off the tops of these nylon spacers, which is the easiest way for me to do, I think. So I'm going to do that. So I just sliced off, you can see that, I just sliced off about a millimetre or so off the top of that, and then that will allow me to install these spacers on this heat spreader without detriment to the seal pads being fitted. So this is the final in this video. I've populated all the components along this front end here, along the output stage. This is board 2, the second one. So I now have a brace. This one has already been set up as previously shown, the voltages and the bias. I've done exactly the same on this board. The only tricky bit is this little badger here, this transistor here, which normally would be there. It's a bit of a tight fit to get the legs on the pads here. It's just tricky. It can be done. I mean, I'd done it with a tip that big. So you just have to be a little bit patient and just carefully solder the first leg on. You have to splay them slightly, you've got to splay them out slightly, but you solder the first leg, probably move it across slightly, line up the second leg, solder, line up the third leg, solder, and this will fit on this heatsink that I've drilled, and the nylon bushes are already installed as previous. So I had to cut off the ends so that focus, that's better, so the ends are just beneath the surface. It's only about a millimetre I'll cut off just beneath the surface of this. The other tricky bit might be these caps. I think they're tantalum, sorry. They're 2U2, 63 volts. You might have to do a bit of digging about to get these, but again, this is targeted at the individual that's already got this board from Avondale, from Les at Avondale, and I think he may well have included some of these hard to find components along with this feedback cap here, which is 100 microfarad, 60 volts or there, but it can be 10 volts actually, doesn't matter. But again, I think this is a solid aluminium or a tantalum, I cannot remember what it is, but apparently these sound the best. I don't think there's anything else particularly difficult. These are 100 ohm 1 watt, these here, 100 ohm 1 watt, there's 4. These are R22 22 ohm, and these are 5 watts, and these are 47 microfarad at 63 volts actuals. I'm just double checking everything, and now that I've built the two boards up, I'm double checking that all the components are installed correctly. And you'll see I've had to fudge this one here. I didn't have, this is a 6K2, I didn't have an this type, William, but I did have a Dale, and it's 12K2, so I paralleled them together. It gives me 6K1, which is well close enough, and the same this side. They're difficult to find, but if you can't get a 6K2 to go in here, in the 750.75 watt, you can put a smaller one, a half watt, if you've got one. I didn't have any. These are 220s. Well, these are 160 volts, but you can use larger voltages if you want. This was supplied, I think this was supplied by Avondale with the board, with the kit. And he might have thrown in some of these as well, including this Zobel network, which is a coil of wire, 1.2 millimeters, wound around a 5 or 6 mil mandrel, and there's a 15R resistor inside. So that concludes the build up of the two boards, the tandem boards, and here's the heat spreader. And just for my sanity, I put 15004 here, here, here and here, an 03 here, an 03 there, 15003 here and here, so that I cannot get them mixed up. And it's all to make it safe. It's so easy to just drop in the wrong ones in the wrong place, and I've heard many people do it over the years. So I'm just double checking that everything's correct. For instance, little things like these diodes, they're in the correct way round. Again, this one, yes, that one's in the correct way round, that's correct. Just checking the polarities on these capacitors. This is a negative side, negative side, negative side, negative side, and this was the positive side. Sorry, I'll keep bumping this camera. This is a positive side, this is a negative, and just double checking everything is in correctly. The transistors are in the correct orientation, they're in the correct way. You can't really go wrong because the shape of the transistor, the body, TO92, that actually tells you which way it should go in, which way it should go in. With these E-packs, they're, again, it shows you which way they go in. So just be mindful. Positive, here's a positive end of this 2U2. You can just see the little positive where you can. Positive designation on the end here, just here. So that goes to the positive end of the board, marked on the board. Same with this 47 microfarad actual. There's an indent in the body of the cap, and that's a positive end. And it's simple things like that. Just double check before you actually put power on it, because if you put power on it and something is in the wrong way round and it goes pop, you could take out a whole load of, it's a whole nonsense for you. So that's that element. We finished that. This is the end of this video. My next video will be, I'm going to be mounting these on these in tandem, mounting them on a heatsink, and that's going to be the next video, and probably I might mount this in the case, but I can't quite work out what I'm going to do, the way I'm going to do it yet. So for now, thanks for watching. Please make any comments, abusive or whatever. Let's have a bit of a giggle. I really don't mind. It makes no difference. I'm doing this anyway. I don't get paid for it. It's just a bit of fun, bit of entertainment, if you want to look at it like that, and it might be helpful to somebody. So keep safe, everybody. Keep well. Stay indoors. Only go out for food and water and a bit of daily exercise. All the very best. This is Laverda, the implementer. See you next video. Bye.